Hello, 8th grade science students. Today we're going to try something a little bit different. So I'm going to kind of video and draw some examples by hand. We're going to start today by talking about making covalent compounds. So our goal is to be able to, for you guys to be able to make single, double, and triple bond diagrams. So tomorrow I'm probably going to have another video with some examples, and then there'll be a little bit of a worksheet to try with that. So first, what is a covalent bond? So there's two kinds of bonds we're going to talk about in this class for the most part, covalent bonds and ionic bonds. We're going to start with covalent bonds. Our definition is that a covalent bond occurs between atoms when two atoms share their valence electrons. So this is why we've been focusing so much on valence electrons, drawing them in every diagram, drawing the Lewis dot diagrams, and the Lewis dot diagrams are going to be very important today. If you can draw a Lewis dot diagram, then you can start figuring out how covalent bonds will work between two atoms. So there's your definition for making covalent bonds. So let's see some examples. So there's three main kinds, which we kind of saw in the opening goal. There's going to be single, double, and triple bonds that we're going to talk about. And single bonds occur when two atoms share one pair of electrons. So let's see an example. So the example we're going to talk about today is CH4. Commonly known as methane. If you use our standard naming method for covalent compounds, it would be carbon tetrahydride. We're not going to use that in this case. We're going to go ahead and just call it methane. So from our work, we can draw the Lewis dot diagrams for both of these. Carbon has 4 valence electrons, so its Lewis dot diagram looks something like this. And hydrogen has 1 valence electron, but only needs a total of 2. So we can draw hydrogen like this. Now, we haven't talked a lot about this, but the subscripts right here, that tells us how many of them we need. So I have 1 carbon and 4 hydrogens. So since I have 1 hydrogen here, I'm just for fun going to draw 1, 2, there's 3, there's 4. So basically what I need to do is find some way of making these all fit together to make that compound. And a little bit of a hint, it's going to be a single bond. So to draw a single bond, what I normally do is we're going to pair up these two from the hydrogen, the 1 electron from the hydrogen with 1 electron from the carbon. Hydrogen can only take 2 electrons to be stable. And what I do to show the bond is just circle right there. Since we have 4 of them, so I've taken care of my carbon and my hydrogen so far, I can go ahead and draw my second hydrogen, bond those together. Take my 3rd hydrogen, bond those together. Take my 4th hydrogen and bond these together. And there is my atom of methane. So now all these, the hydrogen, the carbon, they're all stable. The carbon now has 1, 2, 3, 4, 5, 6, 7, 8, filling out its octet, so it is stable. And each hydrogen has the 2 electrons it needs. They're just sharing them, which makes the molecule stay together. So since they're sharing the electrons, they have to stay together and make that methane molecule. Now, common misconception. So some people want to call this a quadruple bond because the carbon is making 4 bonds. But notice it's single bonds occur when 2 atoms. So this hydrogen and this carbon are sharing electrons. It's a single bond between those 2 atoms. It's not one big quadruple bond. Okay, let's take a look at a double bond. Double bonds occur when 2 atoms share 2 pairs of electrons. So the carbon and the hydrogen just shared 1 pair. The oxygens here are going to share 2 pairs of electrons. So let's start off by drawing the Lewis dot structure for oxygen. If we look on the periodic table, it's going to have 6 valence electrons. So I can go 1, 2, 3, 4, 5, 6. So now you'll notice that these 2 are paired up already. These 2 sets. That's great because that means those are already stable. We don't have to worry about those. It's O sub 2, so I'm going to draw my second oxygen atom, and I'm just going to copy the Lewis dot structure of that one. So now I have my 2 oxygens. You'll notice that each oxygen has 2 electrons that are unpaired. That means those are the ones that need to be paired up in order for the oxygen to be stable, have a full octet, and be a molecule. So I'm going to draw these a little bit differently. So I'm going to now kind of rotate my molecule so my 2 single electrons right here are on the side. Okay, and I've drawn that one. I'm going to redraw the second one. And because I have the same atom, I'm going to go ahead and use a different color just to make it easier for you guys to see. So the next one, let's go ahead and use some purple. So we've got oxygen, 1, 2, 3, 4. Those are stable. These ones are not. So now to make it stable, I'm just going to circle those. They're going to now share those. So you can see that between the two oxygens, there's 2 pairs of electrons being shared. That's what makes it a double bond. And again, it's between 2 atoms. There's a third or fourth atom to deal with in this case. Okay, last example. Triple bond. So a triple bonds will occur when 2 atoms share 3 pairs of electrons. So that's probably what you guessed. That kind of fits our pattern. This time we're going to look at nitrogen. Nitrogen has 5 valence electrons, so its Lewis dot structure looks something like this. 1, 2, 3, 4, 5. Again, I'm going to repeat that because we have N2, so I need to have 2 nitrogen atoms. Now that we have those, let's see if we can't pair them up. So similar to before, I'm going to kind of rotate this so that all the unpaired electrons are on one side of the nitrogen right here, and my pair of electrons that's stable I'm going to put on the left. Again, to make this easy for ourselves, let's go ahead and draw the second atom in purple. So there's my second nitrogen. I have those 3 unpaired electrons as well as the stable pair that's there. Okay, now I can go and pair these up. So these 2 electrons can partner up, these 2 electrons can partner up, and these 2 electrons can partner up. So now I have 1, 2, 3 pairs of electrons being shared, which results in a triple bond between the nitrogens. One thing that's important to keep in mind is, so nitrogen, if you've heard of something like ammonia, that's nitrogen single bonding to 3 hydrogens. So these electrons could be single bonded. That could make it stable as well. Water, if we go back to oxygen, oxygen has 2 unpaired electrons. If we pair hydrogen to those, we would get H2 hydrogens in an oxygen, and we would get water. So all you have to do is pair those up. It doesn't. If you have 2 free ones, it doesn't mean you have to do a double bond. You could do single bonds as well. The reverse is true as well. So carbon looks like it's great for making lots of individual single bonds. So carbon can make triple bonds because it has 3 available electrons. It can make double bonds because it has 2 pairs actually of unpaired electrons, or it actually is very good at making single bonds as well. Okay, so just to reiterate, now we've seen how to make simple single, double, and triple bond diagrams, and we're starting to understand that a covalent bond occurs between atoms when they are sharing their valence electrons. So simple questions to practice today. Tomorrow we'll look at a couple more complicated examples, and then we'll be kind of off to the races with covalent bonds. Okay, fantastic. Thanks for paying attention today. Have a fantastic rest of your day.